Hello, and welcome to the first video for 6.4. We are talking about inverse trig functions. Okay, we're actually going to start this conversation on the cheat sheet page. Okay, I'm just borrowing an example of a triangle. So I'm going to use the 45, 45, 90 triangle. When we first started this chapter, we were talking a lot about reviewing SOHCAHTOA, right? We had sine, or I guess we actually have written it down already. Over here on the other side, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. But what happens when you turn those upside down? Okay, if I look here, then actually I want to use this one because they're not the same on both sides. Sine of 30 is opposite over hypotenuse. We have 1 over 2. But what were to happen if you were to flip that upside down? You'd get what we call an inverse trig function. And the inverse trig functions get their own names. We're going to go ahead and write those down over here in the boxes. We have our classic 3, sine theta. Actually, we're going to write it this way. Pardon me. Sine theta. We have cosine theta. And we have tangent theta. Okay. When you invert them, remember inverse is the same thing as a reciprocal. So 1 over each of these actually gets a whole new name. Now, if you take 1 over so, right, then you don't get opposite over hypotenuse, you get hypotenuse over opposite. Same thing happens with cosine, hypotenuse over adjacent. And same thing happens with tangent, adjacent over opposite. You get the reciprocal function. Okay, now what you can do with these is a whole other branch of trigonometry. It starts leading into calculus. It's super cool. You get these lines and tangents and things of functions, and they're really, really applicable with some of these inverse functions. And that's where they get their names. So their names are a little strange, but when you invert them, that's all you have to do is you have to take the opposite over hypotenuse and change it to hypotenuse over opposite. The inverse of sine is called secant and is abbreviated to SEC, okay? The inverse of cosine, no it's not. The inverse of cosine is secant, pardon me. Cosine is secant. And the inverse of sine is cosecant, which is abbreviated to CSC. The way I remember that is there's only one co per team. So you've got cosecant with regular sine and secant with cosine. You see how there's only one co? So my apologies on that. And again, the reason comes from more of a higher up trigonometry, but if you'd like to know, be happy to tell you. Tangent is much easier to figure out the inverse for. It's cotangent. So they get their own names. You have secant, cosecant, and cotangent, but basically they're just the flips of the 3 that you already know. So we're going to go ahead and work with these in our triangle trig in 6.4. And let me go all the way down there. You've got that same statement right there written here for you. Let's start by finding all 6 for one measure. Okay, and you're going to find that this is actually pretty easy as long as you know 6.2 and 6.3 pretty well. Okay, all right, so here our theta is equal to 5 pi over 6, and they want to find all 6 trigonometric functions. So what do they actually want us to find? They want us to find sine of, well, you know what? I don't know 5 pi over 6 off the top of my head. Maybe I could go check my cheat sheet, or maybe I could just convert it real fast. It looks like 150. So they want sine of 150. They want cosine of 150. They want tangent of 150, our 3 classics. And then what I like to do is write the other 3 in their opposite format. So cosecant of 150, secant of 150, and cotangent, cotangent of 150. They want us to find all 3 of these. Well, I don't know about you, but I don't know how to find the second 3. We do know how to find the first 3 right now. So let's go ahead and draw 150. It's right about there, right? Drop our triangle. Okay, that triangle is now a 30. Okay, we've got a 30. 30, you've got 1, root 3 and 2, but in this case, a negative root 3, right? Negative root 3. And sine would be 1 over 2. Cosine is negative root 3 over 2. Tangent would be 1 over negative root 3 or negative root 3 over 3. All right, so at least we know how to find those. Now, if you didn't know how to find those, you had no idea what I was doing there, you need to go back and rewatch 6.3, okay? But here, we've got these 3 new functions. Remember, they're the inverses of these 3 functions. What does inverse mean? It means reciprocal. So once you have sine of 150 equals 1/2, you know that cosecant of 150 is 2 over 1, or just 2. If you know that cosecant of 150 is negative root 3 over 2, then you know that its inverse, secant of 150, is going to be negative 2 over root 3. Now, granted, that needs to be rationalized, negative root 2 root 3 over 3, but it is still just the inverse. For the cotangent, same idea. I'm going to take this unrationalized version and flip it, because then I don't have to double rationalize. I just have it on the top now. And so I have negative root 3. That's all you need to do to find those trigonometric inverses.